All right, good morning, everyone. It's Mr. Hu here with another lesson. Hope you enjoyed that catch-up day to get caught up on all your work. We are going to dive right into our next little unit here, with leading off of how we ended up the last one with quadratic formula. We are going to talk a little bit about how you solve quadratics without the quadratic formula. And with that, we kind of need to talk about a couple of other things that will definitely help us when we talk about higher power functions, the polynomial functions, the rational functions, all that other good stuff. So today, we're talking about simplifying expressions and solving quadratic equations with factoring. Okay, so a little more factoring today, which might be good if you are a whiz at factoring. I'm going to be using the same old techniques, okay, so nothing too terribly hard. Okay. Our objectives today are pretty simple, straightforward. Okay. First, we want to understand and be able to simplify. So what does simplify mean? Okay, how do we do it? Okay, these kinds of things. Okay, when you think about it on maybe like an initial level, you're like, oh yeah, I know what simplifying is. Yeah. But I'm going to talk to you a bit more rigorously about how we think, how I, the teacher, think about it. Perhaps Ms. Atkins as well. Right. Also, we're going to use factoring to solve quadratic equations. Okay. And what I didn't mention in these two is that we are also going to talk a little bit more about standard form formally. Okay. Even though I know we've already mentioned it, and I know some people probably already know what it is. Okay. Let's go ahead and get started. So let's start with simplifying expressions first. First of, what do I talk about when I'm saying the word simplify? Okay, you may want to take a little, pause here and think about what it means to you. Okay, but when I define the word simplify, I really just mean is the act of multiplying, combining like terms, and then I can also include this kind of idea of cleaning up. Okay, cleaning up your expression. Okay, you kind of want to make it a couple of terms in the same kind of sequence. Okay, if you thought about factoring and how it takes this expression, this link, this like little list, and kind of cuts it up into pieces that are multiplied, okay, together. Okay, this is the act of actually doing the multiplication. Okay, so the result of simplification should be an expression. Okay, with only terms. Now, when I say terms, I mean your string, okay, your expression should only have things being added to each other, separate terms added to each other. That doesn't mean there can't be any multiplication. Okay? So let me give you an example, okay, of such a expression. Okay, we're going to talk about standard form quite a bit here. Standard quadratic form. Okay. Standard quadratic form, of course, is this idea of ax squared plus bx plus c. All right. Now, to kind of put into practice what I mean by simplified, this is a simplified form. Okay? What I mean by that is that I have one term right here, okay, the x squared term. I have another term right here, my bx, x to the first, and then I have a third term right here. And what separates them all is this idea of addition, okay, possibly subtraction also, that is the same thing. But nowhere in it does it look like a factored form. Okay, so that's my definition of simplify here. There are probably many other places to kind of use it, and you might even have to factor in order to simplify an expression if you're talking rationals. Okay, but at least for the purpose of this lesson, simplify means to multiply everything out, combine your like terms, and make it nice and tidy, just like the standard quadratic form. Okay, so let's do a couple of examples here. I will go ahead and leave the definitions up there for you, okay, to constantly refer back to. You can also pause the video to look at it. Okay, so all right, so let's take a look at some examples here. So my goal here is to simplify these expressions. They display my standard quadratic form, okay? And I say expressions, but I know these are equations. So we're going to be manipulating them as if they were equations, all right? So in the first example, there's no real multiplication going on. It's just a bunch of terms out of order, okay? This is probably the easiest form to work with in terms of simplifying because all you really got to do is reorganize the pieces together, okay? Which you all should be whizzes at. Okay, this is some basic algebra stuff, right? So remember, You can choose the left or right side, but I think most people will probably prefer the left side since it's ax squared plus bx plus c equals 0. Usually that's what you want to get. Okay. Or if you want to put it the other way around, that's always fine. Okay. Doesn't really matter to me since in the end you can always multiply through by negative sign. So let's go ahead and do this. First I'm going to find all my x squared terms. Okay. So that'd be this guy right here. So I'm going to go ahead and put him on the left, very left, 2x squared. Are there any more x squared terms? I don't see any. So hopefully unless you see any, then I don't think there's anything to worry about that. Okay, and then I gotta put my plus 3x here. Okay. On the right side I see that 7x, so remember to get rid of something on the right side, you have to do the same thing to the left side. So it'll be minus 7x from there. Bam. Okay. And then finally I have my minus 5, and then to get rid of plus 3, I have to subtract 3, right? Okay. And so that's another minus 3 there. And of course that all equals 0 once all is said and done. Okay. Now that I have all my terms on the left, I can just put them all together by, combining like terms. Again, that 2x squared doesn't have any buddies to pair up with, so just leave them alone. 3x minus 7x, that is of course going to be minus 4x. Okay. Minus 5 minus 3, for a total of minus 8 equals 0. Okay, let's go ahead and box this one out. Okay, now that's our standard quadratic form. Now, if you were looking at this and saying, Mr. Hu, I think I could factor that, I'd say you're right. You're absolutely right. You can even try to do like an ACB tree or something. But when you're simplifying, guys, there shouldn't be any need for factoring. Okay, not at this point anyway. So don't factor these guys. You just want to add up the like terms, maybe do some distribution, which we'll see in the second example. Okay, but no factoring this lesson. Okay, at least not right now. Okay, not right now. When we're talking about simplifying expressions, then we will get to the factoring part. Okay, so on this simplifying expressions part, don't factor. Okay, but if you see it and it looks like it needs to be factored, that's good for later in the lesson. Okay, all right, example 2. I got 3 times x plus 3 equals 2x squared minus 9. Okay, well, this is a little interesting because I have a pair of factors on the left and then some terms on the right. So they're not quite the same thing. So I'm going to have to do a bit of distribution to help me out. So 3 times x and 3 times 3. That is, of course, 3x plus 9. Okay. And I'm still got this 2x squared minus 9 over here. Okay. Then I just got to move everything over to the left side, right? So I'm going to move that over by subtracting it, move this over by adding it. Okay. You know the drill. So I'll have minus 2x squared. That is the first term I'm going to put since it's got x squared in it. Plus 3x. That's still there. Okay. And then I got plus 9. And then plus another 9, right? Because I added it to that side. So that's what I got here. That all equals 0. Okay, so it looks like only one pair of terms to add up there. Negative 2x squared plus 3x plus 18 equals 0. And simplified. Totally simplified. Again, you're looking at this saying, okay, it looks like I can factor it with the ACB tree, Mr. Hu. I'm going to try it. Okay, not yet. Don't jump the gun. We are about to get there, but not quite yet. So hang on to that factoring itch for just a little longer. Lastly here, we've got this example 3. This is probably the most complex you'll see it. This requires some binomial multiplication, or foiling, as it were. So you may have seen the word foiling in the objectives part of the lesson video. Okay. This is what I'm talking about. Mostly it's just square binomials, but you may have to do some multiplication of other binomials at some point. Okay. So, all right. First things first. I can't actually distribute this 4 yet because I don't know what all is in this x minus 5 squared bit. Okay, the problem 4 times x minus 5 quantity squared minus 2 times x minus 5 quantity equals 8. Okay, so let's go ahead and do the foiling first. You have to do the foiling first because you cannot distribute like this and then try to square it. You will get some weird, not quite correct answer. So how do I foil again? Okay, well first let's write it out. X minus 5 and x minus 5. Okay, and you can stick 4 out there, it's fine. Okay, minus 2, x minus 5 out here equals 8. That's all well and good. Okay, x minus 5 and x minus 5. First, okay, outers, inners, last. You remember that? You are all set. Okay, x times x is x squared. X times minus 5 is minus 5x. Minus 5x again. Plus 25. I did that all correctly anyway. And remember, this is still all multiplied by 4. You cannot drop the 4 out there. I'm going to go ahead and do the distribution over here too, just to save ourselves a couple steps. Minus 2 times x is minus 2x. minus 2 times minus 5 is plus 10. Okay. All right, so far so good. Just simplify the inside here a little bit, or you can distribute it. All good. Okay. 4x squared minus 5x and minus 5x makes minus 10x times 4 minus 40x and plus 100 there. Minus 2x plus 10 equals 8. And now I have all terms, so I can start moving my pieces around. All I got to do is take this out, okay, and then combine my like terms in here, which I kind of already started, for a final simplified form of 4x squared minus 42x. Looks like plus 100 plus 10 minus 8, so plus 102. Let me go ahead and erase this a little bit for you. And that is all equal to 0. So that's what we got there. Okay. So again, it's got that nice quadratic standard form. Okay, and again, it looks like you can simplify it a little bit, but again, I would try to hold off. The main point of the first part of this lesson is just to get you to simplify. Then we can focus on the factoring. So step by step, guys. Pause the video. If you got any questions, maybe jot them down somewhere, and then we'll continue on with the solving quadratic equations by factoring, the part we've all been waiting for. Okay, so in our last section here, we're going to be solving some quadratic equations by factoring. So that simplifying bit kind of got us in the mood to get stuff into standard form. That way we can finally do some factoring, okay, to get our solutions, okay? So last lesson, we talked about using the quadratic formula, using a graph, okay, with a calculator. But this will allow you to do it kind of without a calculator, without the help of any external uh, devices, okay? And to that end, they should all end pretty nicely, if I do believe so here. So let's go ahead and hit our examples of a couple of different variations here, you'll see. So the first one, I've just got something already in standard form. It's already simplified for me, so I don't have to do any extra steps trying to get that into the form to work with it. So just take a look at it. It's a trinomial, so you know what method that is. That's the ACB tree. Okay. 1 times 9 is 9, so I'm looking for something that multiplies to 9 and adds up to negative 10. Something like negative 9 and negative 1, perhaps. Okay. So when I do that, I see that a is 1, so I'll go ahead and use that shortcut here. X minus 9 and x minus 1. Remember, that's still all equal to 0. And so I factored my standard form quadratic equation. Okay. And when you've done that, all you have to do is set the pieces, set the factors equal to 0. So x minus 9 equals 0, x minus 1 equals 0. And once you solve for x in both of those situations, you will have your answer. So the first one is x equals 9, and then the next one, of course, is x equals 1. Okay. So let me circle that with a different color so you kind of know those are my solutions. Okay. So those are my solutions there. 2 solutions usually per quadratic. We'll talk about that a little more in the future, but that for now, you're just looking for 2 answers usually. Okay. We'll move on to the second example here. I gotta have to do a little more work here in order to get it into standard form, I believe. I gotta have to move some pieces from the right to the left. So minus 3x, here we go. Minus 1, there's that. Minus 3x, minus 1. So all this stuff cancels out. Don't need that anymore. I got x squared, 3x minus 3x. Line is actually just 0, so I'll leave it off there. Minus 24 minus 1 should end up in minus 25. Okay, and then this is another pattern you guys might have to look out for when you do these problems. Okay, x squared minus 25 should be ringing some bells off that it's a difference of squares. Right, so we got x plus 5 and x minus 5. Okay, if you're unsure about how I got that, okay, take a look at these two terms. X squared minus 25 is a difference of squares. Think about what the base term is, what is being squared to get those two numbers, and then you'll be able to get down here. Okay. And again, just set them both equal to 0. I can actually skip that little extra step in here. You don't have to do that, okay? But it should be x equals 5, okay, and x equals negative 5 for my solutions on that one. Oops, try the right color. All right, so the last example here, oops, I can get the right color anyway. Okay, x squared minus 13x equals negative 5x. So again, I have to do a little more work, but you might notice there's no constant term, there's no number. by itself. Okay. And to get rid of minus 5x, I'm going to add 5x, right, to both sides. And then I combine the like term. X squared minus 13 plus 5 should be minus 8x equals 0. Okay. And then here you would apply the greatest common factor factoring method. What can I take out? It is obviously the x. Okay. X times x minus 8 equals 0. And again, once you get to this factored form, you have to set them all equal to 0. So the first one would be x equals 0. Well, that was easy, right? And the next one is x minus 8 equals 0, so x equals 8. So go ahead and circle this. This is my solution there. Okay. So this is probably a little easier than the last lesson if you were actually doing quadratic formula, but for the most part, I think we all use technology for that. Okay. So this might be a little more challenging because we're not going to let you try and use a calculator for it. Okay. At least not so far, and as showing me all the steps and all that stuff. Okay. But we should still remember this from last time. It's just that the simplifying process as well as the thinking about standard form process will help us prepare for future functions when we talk about the polynomial functions, rational functions, all that good stuff. It'll make more sense when we cover it here, the simple stuff. All right. So take a look at the notes if you need to cover anything else. Okay. And come to class with questions prepared. We'll see you then.